always been a builder, seeking to conquer the waters and lands of his earth for the good of those who will follow him on its surface. Not all regions of the earth are bowed to his will. To the north of Vancouver, up the still fjord, south of the Yukon and west of the Fraser, guarded from man by the granite and ice and winds of the coastal mountains, lies such an unconquered region. It is a region of great resources long held from use, of treasures long locked away from productivity. A region guarded by distances and shielded by storms. A wilderness set off from the modern perimeter towns by its challenging terrain. But now, strange things are happening in the wilderness. Strange creatures are prowling the land. Giants with muscles of metal and blood of diesel fuel, whose steel claws rip away the distances and tear at the terrain, snorting defiance at the storms and chasms. And giants are working in the land, giants of steel sinews, bows, and strain, that man and his children may live in greater comfort and safety and abundance. Giants of metal and power. Man's new race of slaves. These giants labor in a region touched only lightly by the Iron Age and the Bronze Age. To move it at one step into the newest of the eras, the age of the light metals, of the metal aluminum. Aluminum is drawn from an inexhaustible source, the clay bauxite. Bauxite reduced to alumina and smelted by power to a metal which is light and strong. Useful in peace, vital in war. A metal whose lightness releases energy to do things once thought impossible. The alumina is reduced by power, electric power. Power in quantities undreamed of not many years ago. Power enough to light a city or run a railroad. And the power is best made of water, falling water, which turns the wheels of turbines in its fall. If aluminum is to be plentiful and cheap, the power must be cheap. Men must search the world for a place where an inexhaustible supply of water falls continuously from a great height. Here in north-central British Columbia, 400 miles north of Vancouver, is such a place. Here in the shadow of the Yukon, the eternal snows promise inexhaustible water. For 1,000,000 years, the cycle of nature has replenished the water. The snows come, the rains fall, the glaciers freeze and melt, and the rivers flow out, and the water falls again. Here is a model of the region. The water is high in the mountains for power, and near it to the west is an ocean channel where ships can bring the alumina to the power. But the water is separated from the ocean by a mountain wall. The chain of lakes, like a vast, broad tub, drains to the east, through the gorge of the Nechako River. Here the men and the machines will plug the drain with a great dam, and the lakes will begin to fill, rising against the mountain wall which for 1,000,000 years has barred any westward fall. And here the men and their machines will tip the tub the other way. They will drill a new river through the mountain wall, a tunnel 10 miles long. And at the western end of the tunnel, they will turn the water downward to drop 16 times the fall of Niagara to a great powerhouse which they will build inside the mountain. From Kemano, the heaviest transmission line ever planned will carry the energy 50 miles to the northwest, up over the eternal ice and winds of the Kildala Pass and down to the delta of the Kitimat River. Here, the only such place in many miles is level ground, adjacent to the ocean channel where ships will bring the alumina to the power. Enough level ground for a city which will be called Kitimat. But now man comes into the wilderness, making a path not only for himself, but for his new race of giants. Now he can challenge the unconquered regions of the earth on even terms. With his own two hands, a man can do just so much. To do more, he must use his mind. The hands of the mind are machines. The man with a machine has 1,000 hands. To block the eastward flow of the Nechako, the men and their machines will drop a mountain into its gorge. To move the mountain, they must first take it apart. And so they have undermined it with a network of tunnels, hundreds of feet deep. And in the tunnels, they have piled dynamite. Dynamite in whole boxes, 168 tons of it. The roads have been blocked off since dawn. The mountain is waiting. Together, and the machines work together. Each machine does what it can do best, and together they make a team. The men have taken the mountain apart. Now they must move it to the river. And there is little time, for the dam must be closed before winter stops the work, or a year's water will be lost. The trucks roll a round trip every 12 minutes. A loaded truck dumps every 45 seconds. The machines have moved the mountain to the river. Now they must put the pieces back together in the shape of a dam. The river itself helps build the dam which will block its course. 3,000 gallons of it every minute roar against the falling rock, shove and settle the broken mountain into a compact mass that will hold back 150 miles of lakes. The river is dammed by rock and clay. The body of the dam is rock. The impervious core which seals off the water is clay. One machine makes ready for another. The big red crawlers spread the wet clay for the scoops to pick up on the run. As the summer fades and the cold months come closer, a new load of clay rolls to the river every 30 seconds. The machines work together. Scoops drop the clay, the crawlers spread it level, and the sheep's foot rollers compact it into a layer so firm that a cubic foot weighs almost as much as a man. In a few years, here near the dam, the land will be covered as the deep storehouse of liquid power rises toward the western wall. Beyond the storm-shrouded mountains lies the valley of the Kemano, where the power will be made. 10 miles west and half a mile down. Through these mountains, the men and machines are drilling a river. The shore ahead will soon be the bed of the lake. Except for the gatehouse, which will control the flow into the tunnel, there will be nothing above the waters to show that man has passed this way. Here it is that the hard rock men will tip the tub the other way, driving the 10-mile tunnel which will carry the water from the lakes to Kemano. This giant is a drilling rig called a jumbo. On its 4 levels, 16 drillers push hardened steel into the rock. 12 feet, 13 feet, 15 feet to a blast. The hard rock men go where the work is. One continent or another, there is little difference under the ground. The lights gleam yellow in the haze. The water drips shining down the jagged walls, and compressed air roars against the clang and hammer and scream of the drills. Drill, load, and shoot. That's hard rock. 2 hours to drill, an hour to load the holes with dynamite. This machine is a Mucker, a dragon eating a hole through the mountain, banging its jaws against the tunnel face as it hurls mouthfuls of shot rock back through its iron throat into the ore cars which will carry it away. Half a mile above the valley floor, a camp clings to the mountain. Below the aluminum buildings is the west entrance to the tunnel, deep in which men are driving eastward to meet the men boring west. Drill and load, shoot and muck. The men go in, the rock comes out. Here the water must turn downward on its plunge to the turbines. But even 12-inch armored steel penstocks would burst under this awful pressure. And so the men are making their penstocks out of the rock itself. They will plug the main tunnel a half-mile in from the face and drill slanting tunnels downward through the very heart of the mountain to make a fall 16 times the drop of Niagara. This is where the water will plunge down inside the mountain. Kemano is the central camp of the project. Here will be the power plant. If the water falls inside the mountain, how would it be brought outside to a powerhouse? Like all great ideas, the engineer's answer was a simple idea. They would build their powerhouse inside the mountain. A quarter of a mile inside the mountain, at the bottom of the penstock tunnels, the machines muck out the power cavern. 2 city blocks long, 10 stories high, vast enough to enfold a cathedral in its rocky embrace. Drill and load, shoot and muck. The men start at the roof and blast their way downward, shooting the floor and dozing the rock into holes, to fall through the mountain to the shovels and trucks which work on the bottom level. The men go in and the rock comes out. Out the same tunnel from which soon a foaming torrent will burst on its way from the turbines to the river and thence to the sea. There to be picked up by the sun and fall again as snow and rain into the high lakes. Here in the swift northern rivers, the big red crawlers go fishing in business hours. Concrete to line the power cavern and the tunnels, concrete to support the transmission line towers, Concrete must have gravel that is sharp and clean. And a few yards from the tunnel portal, nature washes gravel so bountifully that the crawlers need only to push it into the path of a tractor-powered drag line. On this project is gathered a concentration of heavy equipment, probably greater than any outside of a war. The job uses 52 of the huge TD-24s alone. The same big red diesels that power the crawlers drive the gravel plant, and concrete will line the stomach of a mountain. Here in the wilderness, the men are building a shadow town. But when the turbines start to sing, town will vanish. There will only be a few houses here. But now the shadow is very much alive, kept alive in the tradition of construction camps over the globe, on pie for breakfast and steak for lunch. With his two hands, a man can do just so much. Soon this man may be doing it with one. Here where the power is made, there is no level land for the smelter, and so the power must go where the work is. Each tower is designed separately for its own load and position, and the cables will be thick through as a man's arm, swinging 3,000 feet in a single span over the ribbed blue ice of a glacier. The line starts near sea level, here in the valley of the Kemano, and in a few miles it climbs to the clouds. In the beginning, there was no road, and even now the road is steep and slow. And so again the men call on their giant. It carves a road with its wings. Light loads can go up the line by air, but the men need steel and cement and cable and machines. And so they are driving a road up the cliffs, blasting a narrow shelf out of the sheer rock walls. Air compressors for the drillers, power units for the highliners. The heavy equipment goes up on timber skids, which are little changed from the days of the lumber crews. Rock falls and the snow slides and the road goes out, and the men and the machines put it back, and the road keeps climbing. In the spring there was no road here. The men were stopped 2 miles below the pass, and the tortured rock ahead was overlaid with 100 feet of snow. On May 14th, Albert Charon, a French-Canadian, and a helper named Bill Henry, took a TD-24 crawler out onto the vast upsloping snowfield. Early on May 17th, they reached the bottom of the narrow chute which pierced the final head wall. The helicopter dropped fuel, and the huge crawler began grinding its tracks up the almost vertical chute. From far below, the men watched. Suddenly, the snow gave way, and the big red crawler began to slide and spin, sledding 400 feet back down the snow cliff, when miraculously, its tracks piled up enough snow to stop the plunge. The next day, Charon and Henry started up again. On May 21st at 8 p.m., they leveled their tracks on the summit of the pass. The Glacier Creek Road was licked. Drill and load, shoot and muck. Shoot the holes and muck out the shot rock. The rock goes over the most beautiful dump in the world, and the road goes down the Kildala. Over the pass and down the Kildala, the men and machines have gouged a shelf in the rock. It looks so easy after it is done, but it is not easy in the doing. One gang works from the top down, another gang works from the bottom up, and when they meet, there will be a road for the line. Shoot and muck up in the rock, doze and fill down in the rainforest so that trucks can haul supplies for the line. The power can go from Kemano to Kitimat. Wants to go to Kitimat? Man will go to Kitimat. "50 miles away, the water falls inside a mountain, and the power comes from Kemano to Kitimat. The way has been cleared through the forest. The road for the girders and cement and cable is coming down the Kildala, and soon the line will carry the power from the lakes to the smelter. The land is level here, the only level land in many miles, and near it is an ocean channel for a new deep water port to serve the broad and fertile hinterland. The land is level, but the land is unstable here near the shore, made of water and saturated sand and fallen trees, 1,000 generations of fallen trees, which must be stripped to the rock and replaced with good hard gravel. A mountain of gravel, shovel by shovel, and truck by truck. The hard gravel goes down to the rock now, and the foundations will be solid. And soon a smelter, 1.5 miles long and 1/2 mile wide, will provide the life force of a new city. A city which will start its life with more than 6,000 people and may grow to 50,000. But now the homes are yet to be built, and so the work of clearing goes on. And all the trees that men will clear for their city are fewer than fall in these vast forests in a single winter storm. Steel ball holds the chain low on the trees, and the chain, pulled at each end by a plunging crawler, does a year's work in a week. Vancouver, guarded from man by the ice and granite of the coastal mountains, lies a region which once was unconquerable. Soon it will yield its treasures of energy and abundance. But there are vast regions still unconquered, still with their treasures locked behind nature's barriers. Barriers which now may be breached by man's new race of giants. For a man's two hands can do just so much. To free himself from drudgery, he must use his mind. A man's hands could do just so much. To do more, he has used his mind. The hands of the mind are machines. The man with the machine has 1,000 hands. And he and his children a better life.